right, so we're going to take notes on 2.6/2.7. We're going to talk about rational functions and asymptotes. So rational function is a fraction and a function. It's when we have a polynomial in the numerator and in the denominator. An important thing to note on this page is that the domain of a rational function is the set of all real numbers except the x values that make the denominator 0. Remember, we can't have 0 in the denominator. Now, we've talked about domain before, so this is a little bit of a domain review. It says the domain of a function is the set of all real numbers except if there is a variable in the denominator. We would set whatever's in the denominator not equal to 0. Our denominator cannot be 0. If there's a variable under a square root, so if I had the square root, we would set whatever's under our square root greater than or equal to 0. And if that square root is in the denominator, we would set whatever's under the square root just greater than 0, because if it's in the denominator, it can't be equal to 0. So example 1 says find the domain of the rational function. So to find our domain, what do? Set the denominator not equal to 0. Perfect. So when we solve for x, we're going to add 4 to both sides. So x does not equal 4. So our domain would be all real numbers, I'll abbreviate here, all real numbers except 4. Now WebAssign, I think, is going to want this in interval notation. So to write this in interval notation, it might help us to put it on a number line. We're talking about everything except 4, so I'd have a hole at 4. So everything to the left and everything to the right of 4. How would we say this in interval notation?
Negative infinity. 4 infinity.
Awesome. Negative infinity to 4 with a union and 4 to infinity. So everything before 4 and everything after 4. It's all real numbers except 4. All right, example 2. I want to find the domain of the rational function again. What would we do? Set the denominator not equal to 0, and we solve. So x squared does not equal, we're going to add 36, bless you, to the other side. So x squared does not equal 36. What would we do next? Square root both sides. So what does x not equal? Plus or minus 6. Awesome. So we'd say all real numbers except 6 and negative 6. But if I put these on a number line to help with our interval notation, I'd have a hole at negative 6 and a hole at 6, but it's everything before, in between, and after. So how would we say this in interval notation? Negative infinity to negative 6. What would come next? Negative 6 to 6, and then 6 to infinity. Awesome. So domain kind of goes hand in hand with vertical asymptotes. An asymptote is like an imaginary line, not imaginary, but it's an invisible line of our graph where our graph gets really, really close to that number, but doesn't touch. So here we have a vertical asymptote. To find the vertical asymptote, we set the denominator equal to 0. So our vertical asymptote here would be x equals 0. So we'd have a vertical line through 0. So notice how our graph gets really, really close to our asymptote, but does not touch. So with rational functions, a lot of times we'll have vertical asymptotes or horizontal asymptotes where our graph gets really, really close, but does not touch the asymptote. We're going to skip the arrow notation for now. We might come back to it tomorrow, but we don't really do anything with it. So to find our vertical asymptotes, we set the denominator equal to 0. So it's similar to finding the domain because we set the domain, we set the denominator not equal to 0 because we don't have a part of that graph in our domain, but whatever that line is where we don't have part of our graph, we have a vertical asymptote. So looking at the picture on the left, we would set our denominator equal to 0 to find our vertical asymptote. Add 9 to move it to the other side. So x squared equals 9. Then what would we do? Square root both sides. So square root cancels out with the squared. X equals what? Plus or minus 3. So we have two vertical asymptotes here. We have x equals negative 3 and x equals positive 3. So notice how in this first graph on the left, we've got a vertical line for our asymptote at negative 3 and a vertical line for our asymptote at positive 3. We're going to skip the middle graph for now. It's got a hole in it, and we'll talk about holes tomorrow. But let's look at the one on the right. So again, to find the vertical asymptote, we set the denominator equal to 0. Here I would add or subtract 9 from both sides. So x squared equals negative 9. Then what would we do? Square root both sides. So x equals what? Plus or minus 3i. Can I have an imaginary asymptote? No. So here we have no asymptote. So asymptotes cannot be an imaginary number. They're only real things. So if you got an imaginary number, we've got no vertical asymptote. So going back to the last slide, we'll look at the examples here. So here I have 4x over 2x squared. So if I have x to the first power on top and x to the second power on the bottom, my degree on top is less than the degree in the denominator. So what would my horizontal asymptote be? Y equals 0. Remember, it's a line, so it's not just 0. You got to make sure you include that y equals. Looking at the example in the middle, our degree on top is 2 and the degree on the bottom is 2. So I look at my coefficients. So what would my horizontal asymptote be here? Awesome. Y equals 4 over 2, which simplifies to 2. And then in our third example, the degree on top is 3 and the degree on the bottom is 2. When my degree on top is greater than my degree on the bottom, what's my horizontal asymptote? None. Perfect. Good job. So to find horizontal asymptotes, we've got 3 rules. So it says if the numerator, meaning the degree of the numerator, is less than the degree of the denominator, then the graph has a horizontal asymptote at y equals 0. So if I had something like x over x squared, the degree of my numerator is less than the degree of my denominator, then my horizontal asymptote is y equals 0. If the degree of my numerator is the same, if it's equal to the degree of the denominator, then the graph has a horizontal asymptote at, this would be the coefficient. So let's say I had 3x squared over 4x squared. If the degree is the same in the numerator and the denominator, we look at the coefficients. So here, my asymptote would be y equals 3 over 4. And then if my degree of my numerator is greater than the degree of the denominator, then there are no horizontal asymptotes. So if I had something like x squared over x, there'd be no horizontal asymptotes. So example 3 says find the horizontal and vertical asymptotes, if any, of the graph of the rational function. So let's start with we can find the horizontal asymptotes first, so what we just did. So horizontal asymptotes, we look at the degree. So if the degree on top is less than the degree on the bottom, what would our horizontal asymptote be?
0.
Just 0? Y equals 0. Perfect. Next, our vertical asymptotes. What do we do to find our vertical asymptotes?
Set the bottom equal to 0.
Set the bottom equal to 0. So here we've got x squared equals 36. What do we do next? Square root both sides. So what does x equal? Plus or minus 6. So our vertical asymptote is x equals plus or minus 6. I'm sure on WebAssign it'll make you put them separate. So x equals positive 6 and x equals negative 6. We've got two vertical asymptotes here.
How do you get the horizontal?
Horizontal asymptote, you look at the degree. So our degree of our numerator was 1 and the denominator is 2. Since the top is less, it's y equals 0. Next, just for fun, let's find our domain. How do we find the domain here?
What? You said the denominator not equal to 0?
We set the denominator not equal to 0, which we just solved when it was equal to 0. So instead of equals, we can just make it not equals. So our domain would be all real numbers except 6 and negative 6. So it's always going to be the same values as your vertical asymptotes. Vertical asymptotes and domain are going to be the same numbers. But how would we write our domain in interval notation? Awesome. So negative infinity to negative 6, negative 6 to 6, and then 6 to infinity. Perfect. Any questions here? All right, let's do B. Let's start with our horizontal asymptote. So horizontal asymptote, we look at the degrees. Our degree on top is the same as the degree on the bottom. So then what do we have to look at? We would look at our coefficients. The coefficient on the bottom is 1. So our horizontal asymptote would be what? Just 3 over 1? Y equals 3 over 1, which is 3. Next, let's find our vertical asymptotes. How do we find the vertical asymptotes? Set the denominator equal to 0. So x squared equals 4 when we add 4 to the other side. What do we do next? Square root both sides. So x equals plus or minus 2. So our vertical asymptote, we can say x equals plus or minus 2. On WebAssign, it'll make you put this as separate lines. It'll probably give you 2 boxes. X equals 2, x equals negative 2. Now let's find our domain. What would our domain be? X, what?
What?
X does not equal what? Santi, stop. Kakit, you had it. What is it?
Wait, what?
You had it.
X is
Not 0.
to negative 2.
X does not equal 2 and negative 2. Perfect. It's the same values as our vertical asymptote. How would we write that in interval notation? You got it?
No.
Pearman, help him out. Pairman, just, you can tell me. What is it?
I think we should just say the answer.
Leo.
Negative. This is negative infinity, negative 2, u, parentheses, negative 2 to u, to infinity.
Awesome. Negative infinity to negative 2, negative 2 to 2, and 2 to infinity. It's all real numbers except negative 2 and 2. So we have to include that or show that gap in negative 2 and 2. Any questions here? All right, let's look at C. So let's start with our horizontal asymptote. Horizontal asymptote, we look at the degrees. When the degree on top is less than the degree in the denominator, what's our horizontal asymptote? Just 0? Y equals 0. Now let's find our vertical asymptote. What do we do to find the vertical asymptote? Set the denominator equal to 0. So x squared, when I subtract the negative 1 to the other side, x squared equals negative 1. What would we do next? Square root both sides. So x equals what? plus or minus 1i, or just plus or minus I. Can I have an imaginary vertical asymptote? So what's our vertical asymptote? None. All right, and now for a challenging question. What would our domain be here? All real numbers. Perfect. So how would we write that in interval notation? In interval notation. Negative infinity to positive infinity. Thank you. So our domain here, we would set it x does not equal to, but it's an imaginary number, so x would be all real numbers, or our domain is all real numbers. So the graph of a rational function has a slant asymptote if the degree of the numerator is 1 more than the degree of the denominator. And just like when we were talking about before with our horizontal asymptotes, if the degree in the numerator is greater than the degree in the denominator, we're not going to have a horizontal asymptote. So you're not going to have a horizontal asymptote if you have a slant asymptote. So when the degree in the numerator is 1 more than the degree in the denominator, you'll have a slant asymptote. The equation of a slant asymptote can be found by division. It's the equation of the dividend with the term containing the remainder dropped. So we drop the remainder. So our slant asymptote is going to be in the form of y equals mx plus b. When we divide, we only care about the x and the constant number. Whatever our remainder is, we're going to drop it. So we drop the remainder. Doesn't matter. So again, our slant asymptote, it's slanted because it's going to be a line. It's going to be some type of line. It's just not a vertical line or horizontal line. It'll be some line with a slope. So it's going to be in the form of y equals mx plus b. So let's take a look at example 6. We want to find the slant asymptote of the function. So we're going to divide. So x goes outside the box. Inside, we've got x squared plus 6x plus 2. Step 1 in division is divide. What's x squared divided by x? X, so I'm going to write that on top of my x term. What's step 2? Multiply. X times x would be x squared. Change the signs and combine, so x squareds cancel. What's next? Drop down the 6x. What's 6x divided by x? 6. Then we multiply, we get 6x. Change the signs and combine. We can drop down the 2. Can I divide 2 by x? No. We also ran out of numbers, bless you. So whatever we have left, 2 would be our remainder. What did we say that we do with the remainder? Drop it. Get rid of it. Whatever your remainder is doesn't matter. So our slant asymptote here is like the whole number part, I guess. That's what we can call it. But our slant asymptote has to be a line. We said it has to be in the form of y equals mx plus b. So what am I missing here? Awesome. So it'd be y equals x plus 6. So that would be our slant asymptote. Now, if you have an x squared on top and an x plus a number, x minus a number on the bottom, I'm okay with you doing synthetic division. For this one, inside the box, I have 1, 6, and 2. What do you think would go outside the box? So x is what we're dividing. This is just x. Is it x minus 1? No, that's different than just x. What do you think the number is that I'm subtracting from x here? 0. So 0 would go outside the box. We drop down the 1, multiply, we get 0, add 6, multiply, 0, add 2. So here I'd have x plus 6, remainder 2. What did we say we do with the remainder? Drop it. Get rid of it. So y equals x plus 6. This would be the same. So you can use synthetic division. Just make sure you're careful with it, especially if you just have x on the bottom. You got to know that that's x minus 0, so 0 goes on the outside. And it only works if you have x squared on top and x on the bottom, or x plus a number on the bottom. Any questions here? On the next page, can we do synthetic division here? No. I've got an x squared that I'm dividing into it. So it's not just x plus a number, x minus a number. So we can't use synthetic division. So outside the box, I have x squared plus 2x plus 2. Inside the box, we got to make sure we include all of our terms. So what are we missing? 0x squared and 0x. So I have to put x cubed plus 0x squared plus 0x minus 1. So you need to make sure you put those inside as placeholders. If it's outside, you don't need the placeholders, but inside the box you definitely do. All right, step 1 is divide. What is x to the third power divided by x squared? X. Perfect. So I'm going to put that on top of my x term. Then we multiply. We're going to multiply x times everything out front. So we get x cubed plus 2x squared plus 2x. What's next? Change the signs and combine. So x cubes cancel. This would be negative 2x squared minus 2x. What's next?
Multiply by negative 2.
We divide. Negative 2x squared divided by x squared would be negative 2. Then we multiply by negative 2. So we get negative 2x squared minus 4x minus 4. Change the signs and combine. X squareds cancel. This would be 2x plus 3. Can I divide 2x by x squared? No. So this would be our remainder. And what do we do with the remainder? Throw it out. Drop it. Get rid of it. What would our slant asymptote be here?
Y equals x minus 2.
Awesome. Y equals x minus 2. Perfect. You cannot use this to help you with the test and quiz. So this is just to help you study. You will not get this on the test and quiz. This needs to be in your brain when it comes time for the test on Tuesday next week. So on your cheat sheet, for the domain, you set the denominator not equal to 0. Vertical asymptotes set the denominator equal to 0. So domain and vertical asymptotes go hand in hand. Vertical asymptotes will always be x equals. Horizontal asymptotes are always going to be y equals, because they're a horizontal line. If your numerator is greater than the denominator, there is no horizontal asymptote. If your numerator is the degree of the numerator is equal to the degree of the denominator, then you look at the leading coefficients. That's what the LC means, the leading coefficients. If the degree is less than, if the degree of the numerator is less than the degree of the denominator, then our horizontal asymptote is y equals 0. Slant asymptotes, we use long division. To find the y-intercept, we evaluate f of 0, so that means we plug in 0 for x. To find the x-intercept, we would plug in 0 into y, but kind of like a shortcut of that is you just set the numerator equal to 0. And then we'll talk about wholes tomorrow, but to find the wholes, we factor the numerator and the denominator. So we'll talk about the x-intercept, y-intercept, and wholes tomorrow, and we'll actually graph them tomorrow too. But you guys can start the WebAssign. I don't think that there's many questions on the WebAssign where you have to like graph. I think a lot of them are just finding the asymptotes. So you guys can start the WebAssign. I think on Canvas it says due tomorrow, but I'll change it to Thursday. I'll give you guys 2 days because we'll finish the notes tomorrow.